Okay. So in this, we're going to go over reciprocal functions, what they are, how to graph them, and what they look like. So this is just going to be a quick intro, but if we have there is y equals the function of x, then the reciprocal of this is going to be y equals 1 over the function of x. So it's just the function, and now it's 1 divided by the function. So let's try a very simple case. Let's say we have y equals x. So the reciprocal of that is y equals 1 over x. Okay, so why don't we just try to investigate this through graphing? I think that's the easiest way. So I'm going to draw this. This is y and x. So let's just draw the original function. So we're going to draw a line. And this is y equals x. Now, how would we draw the reciprocal? Well, what happens when x is 0? Well, if x is 0, y is 0 for the original function. But if x is 0 here, I get y equals 1 divided by 0. So that makes no sense, right? Like we can't divide something by 0. So we actually get something on this, and it is our vertical asymptote. And that's going to be x equals 0. So the vertical asymptote is a line right down the middle that cannot, it just says whatever this is, it cannot touch this line. Okay, so now we have this vertical asymptote, so I kind of divided it into two halves. Well, what happens if x is really big? So let's say x is 500. So if x is 500, then y is 500. But what if it's here? Well, if x is 500, then y is 1 divided by 500. So it's really small. Okay, well, what happens if it's 10,000? Well, it's still a number, but it's really small. What if it's a million? It's still a number. Like, no matter what I do, no matter how big x gets, y can never be 0. It can never be so big. X can never be so big that 1 divided by it equals 0. So I have this other line here, and this is y equals 0, and that is my horizontal asymptote. So there's these two lines. So now I've kind of just said, well, you can't cross this line and you can't cross that line. So now we have these two sections that we're stuck in. Okay, so, or there's four possible sections, but we're going to be stuck in two of them. So why don't we just say, well, when does this equal that? When does my original function equal my reciprocal function? Well, that's easy. I just say, well, when does x equal 1 over x? Well, let's solve for x. That's just x squared equals 1, which is x equals plus minus 1. Okay, so when x is 1 and when x is minus 1, they're the same. Well, okay, here's my graph. So there's a point there, and there's a point there. So if x is 1, then y is 1, right up here. And if x is negative 1, y is negative 1. Okay, I should have drawn that so scratchy, that line, but that's fine. This is just my horizontal asymptote. I was trying to give it depth. Um, so now I have these 2 points. These are 2 points on the reciprocal function, and I can't cross this line, I can't cross this line. So I'm stuck in here, and I'm stuck in here. Now, well, what happens as I get close to 0? Let's say y of x is going closer and closer to 0, right? Like x is getting smaller and smaller. Now, if x is getting smaller, y equals 1 over x. Now, as, oops, sorry, as x goes to 0, And I'm going to put a little positive sign. So as x goes to 0 from this side, right, the positive side, what happens? Well, then this is going to be, if it was x is 1, that's just 1. If x is 0.1, now y is 10. If x is 0.0001, now it's going to be 1,000. So as I get smaller, y gets bigger. So as x goes to 0 from the positive side, y goes to the positive infinity. That's kind of cool. So what I'm seeing then is as this goes to 0, y is going to get bigger and bigger and bigger. So it shoots up. Now, what happens as x goes to positive infinity? Well, as x goes to positive infinity, this is going to be positive, but it's also going to be very small. It's going to be y is going to go to positive 0. So it keeps going that way. So if I chose x is 2, well, if x is 2, then y is 1/2. It's half of this. If x is 3, it's a third. So we can kind of see the pattern. Okay, well, now we've got this. Well, let's try the negative. So what happens as x goes to 0 from the negative side? So it's coming in from this side. Well, if it's coming in from that side, then 0, it's going to be very close to 0. So y is going to be very big, but it's going to be a negative. So it's going to be going down. It's going to keep getting closer and closer and closer to the vertical asymptote, but it's going to be getting very, very small. Y is going to go to negative infinity. Okay, now what happens as x goes to negative infinity? So now we're going down this line. We're going to go further and further to negative infinity. What does y do? Well, this is going to get really, really big, but a negative. So this is as a whole, it's negative, but it's going to tend to 0. So now it's going to be tending to 0. So if we had, negative 2, that's 1 divided by negative 2, which is negative 1/2. So we have this type of graph. So this is how we graph these types of functions. And this is kind of all I want to leave it at. I'm going to graph it slightly better so you can see. Actually, let's do something. Let's say y equals x minus 1, and my reciprocal is y equals 1 over x minus 1. So this is minus 1. This is x, y. This graph is x minus 1, this line. Okay, so here, now when x is 1, that's my vertical asymptote. So now when x equals 1, this is my vertical asymptote. Okay, I still have y equals 0 is the horizontal. This is a horizontal asymptote. And now what we're going to do is just graph it really quick. So what we're going to have is something like this. I just wanted to make a graph that might look a little bit more, I think, more intuitive, but it essentially looks the same. But that's kind of what happens. So now we subtracted 1, but it actually just shifted the whole graph over 1. So if we added 1, it would shift it this way. Okay.